Hello everybody, welcome to the Chapter 5 quiz study video. In today's video, I will be going over problems that will almost resemble the problems you will see on your quiz tomorrow. So when you're looking at these problems, as long as you feel confident as you're going through these slides, you'll do very well tomorrow. Alright, so let's get started. The first question is going to be something of review. You'll see a line on a graph, and they'll ask you to write the equation for that line. So this is nothing new, nothing too much of what we've been learning, although it is kind of connected to it. This should look like review, where we want to write our equation in y equals mx plus b. When you're solving this one, we're trying to figure out what our m is and what our b is. Our m is our slope, and our b is our y-intercept. So probably the easiest one to see on the graph is our y-intercept. That's where it's going to hit our y-axis. We see that we're hitting it at the point 0, 4. What that tells me is our b is positive 4. The other piece we need to figure out is what is our slope. The easiest way looking at a graph is to do your slope triangles, figuring out your rise over your run. So for my rise, I'm going to go up 1 and over 3. So when I go up 1 over 3, I'm getting a slope of 1/3. So y is equal to 1/3 x plus 4. Another way you could have solved this one is you could have done your change in y over change in x, and done 5 minus 4 over 3 minus 0, which will leave you with 1 over 3. Both are acceptable ways. Just remember that you have to have your y's on top. A very common mistake is people will put the x on top. So please make sure you've got your y on top if you're solving it algebraically. Otherwise, looking at the graph is another great solution. So for this one, all I'm looking for is y is equal to 1/3 x plus 4. Moving on to the next one, here's where we start bringing in some of the newer things from Chapter 5. It says, what kind of sequence is this and how do you know? So for this one, you should look at the sequence and think about, well, what's happening? How do I get from 6 to 3? And then how do I get from 3 to 0? We find out that we can subtract 3, and we'll see that that pattern continues. With this one, we know that we have an arithmetic sequence. I know that when I talked to you guys, I said arithmetic is the same thing as adding, but hopefully through the poster projects, you kind of saw that adding and subtracting go together, and multiplying and dividing go together. So we know that we have an arithmetic sequence. And that's because if we think about the definition of an arithmetic sequence, is that it's increasing, or we are, in this case, decreasing. We're adding -3 each time, or by a constant term. Or you can say we're adding by a constant. Even if we're subtracting, plus negative is the same thing as subtracting. Once we got that down, we want to make a table and a graph. So in this slide, you'll see me make the table, and the next slide will be the graph. So for our table, here's what's going to be really important, is that the values we see in our sequence are our t of n values. They're like our y values. Really what we have is x's and y's. So our outputs are the sequence, the numbers that we're seeing written there. Our 6, our 3, 0, -3, 6. And then up top, our n values are what number in the sequence is it? What term is it? The nth term. So my first term is my 6. My second term is my 3, 3rd, 4th, 5th. And then they want us to predict that 6th term, which we know if we're going, that should be negative. If we're going down by 3, our next one will be -9. So we'll take this information and we will plot it in our graph. Again, understanding that Our nth term really just means what number is it in the sequence. So our first number is 6, our second number is 3, third is 0, fourth, fifth, and so on. All right. So then when we're going to plot that, we made that table of values. Again, I'll do that really quick. Thinking about it as x's and y's, our first term was 6, our second term was 3, our third term is 0, our fourth term -3, fifth is -6. So when I go to plot it, I'm going to plot those points on my graph. 1, 2. We've got 1, 6, 2, 3, 0, 3, or sorry, 3, 0, 4, -3, 2, 3, and 5. Once we've plotted it, we're just plotting the dots. Remember that all sequences, not just this one, all sequences are discrete, which means there will be no lines. So do not draw any lines on this graph. And that's what I'll be looking for tomorrow, is to have a discrete graph. All right. Continuing, we're still working with the same sequence. Now what we want to do is we want to write the equation for the sequence. So we figured out what our generator is. Our generator is very much like our slope. It's that constant term that we're either increasing or decreasing by. So when we go to write it, we're writing it for y. Remember our y's were our t of n's is equal to whatever your generator is, and then plus your starting value, plus your 0 term. All sequences will start with the first term, so we'll need to go backwards by adding 3 to get our 0 term, which is a positive 9. And that's our equation. We can then check our equation. If I want to find the third term in my sequence, well, 6 was my first, 3 was my second, 0 is my third. So what I'm going to do is I'm going to find the third term in the sequence to check to make sure our sequence works. So I think, or I know that t of 3 is equal to 0. So I want to find t of 3, and if it's equal to 0, then our equation is correct. So -3 times 3 plus 9. When we do that, we'll get -9 plus 9, which is equal to 0. So our equation checks out. All right. You do not have to know how to check your equation. I just wanted to show you that this does work and kind of why this equation is working. All right. Next, they asked us to complete the following patterns. So we can see we've got 8, then 11, 14. So I see that my pattern is that this time I'm increasing by 3. So it says, what kind of sequence is it and how do you know? We know that we are dealing with, again, another arithmetic sequence. How do we know? We know that we're adding a constant term. Where we have a common difference of +4. What is our +3, sorry. When they say what is the generator, they're talking about what's the pattern, what's our common difference. We've got a generator of +3. And finally, here's the big question, the money question. What is the domain of this sequence? So the domain is really referring back to our possible x values. Remember, x's are our n is 1, 2, 3, 4, 5, 6. So, for example, our 6th term in the sequence is 23. Our domain is our n values. So when you think of the domain, think of your n values. So for this one, there's 2 possible answers you might want to list. One is you can just list the numbers that are in the domain. 1, 2, 3, 4, ... ... 4, 5, 6. 6. 1, 2, 3, 4, 5, 6. 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82, 83, 84, 85, 86, 87, 88, 89, 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100, 101, 102, 103, 104, 105, 106, 107, 108, 109, 110, 111, 112, 113, 114, 115, if you want to be a little bit more specific, what I'm really looking for is to see that you know that our domain is our whole numbers. Oops. Our whole numbers. Meaning there aren't any negatives. And there's no fractions. One of the reasons all real numbers won't work out is because, an example, 2.5 falls into the all reals, but 2.5 can't be an answer. It can't be something we're looking for. We can only look for whole numbers, the first term, the second term. So our domain is whole numbers. All right, so then we're going to move on and we'll give you a new question. It says, what type of sequence does this graph represent? So we can see that it's a discrete graph because there's no line that's connecting them, and it looks like we're moving at a constant rate of change. If I wanted to, I could almost draw a line that goes through them. I might have to play around with my line a little bit. But I could get it to go through all of the dots perfectly. We have a linear function, and really what we're seeing here is we have something that's arithmetic. We know that if it was geometric, we would see a very rapid increase or decline. So right now we have the arithmetic. An example of a geometric is it could even start at the same point, but then it would grow at a much faster rate. Or maybe on the other hand, it would decrease at a very constant rate. So it could start it up here, and then it would decrease very quickly. If you see something that forms a straight line, we want to think arithmetic. Anything geometric will be curved. And that's what you can look for on those graphs when you're trying to determine which one should be which. All right, that completes all of the new stuff that you'll see on the quiz. These last two slides that I'll go through are review problems that will also be on there. One of the big ones is going to be solving systems of equations. So with this one, there's two different ways you can go about it. I'm going to show you using the elimination method. So when we're wanting to eliminate, I'm going to want to eliminate one of my variables. I think what I'm going to do is I'm going to choose to make my x's go away first. So if this is a positive 2, I know eventually I want a negative 2. So I'm going to take and multiply that entire bottom equation by negative 2. So my first equation stays the same as 2x plus y is equal to 60. And then on the bottom, I'll have a negative 2x minus 4y is equal to negative 150. From there, I now have my coefficient. One is positive, one is negative, but they're both 2. So 2x minus 2x is going to cancel out, eliminate, and it's going to leave me with just my y. So I'll have negative 3y is equal to, and that should be negative 90. Then I've got a nice easy problem. Negative 3y is equal to 90. So what times negative 3 gives me 90? Well, that's going to be a positive 30. So we now know what y is, but remember with these problems, we want to know our x and our y. So we'll go back and we'll plug it into one of our original equations. I'm going to pick the first one. So I know that 2x plus y is equal to 60. So 2 times x plus 60 is equal to, that should be, for my y, should be what my y value was, which was 30. And then we'll subtract from both sides. When we do that, we're left with 2x is equal to 30, and then divide both sides by 2. X is equal to positive 15. So this is just one example of ways that we can solve for systems of equations. Definitely going to have one of those on there tomorrow, so I would make sure that I know how to solve a systems of equations. The last two is we're going to simplify with our exponents. So with part A, it looks a little crazy. We've got multiple z's and multiple y's in there that we're going to want to combine together. This 2 doesn't really combine with anything. What I want to show you in A is how to write it the long way out. Because what happens is some people think, okay, do I need to add the exponents or do I need to multiply the exponents? So let's write it out the long way and see. We've got 2 times, and then we've got 4 x's. So x times x times x times x. Then we've got times y times z times x times x times x times x. And then times y times y times y. This is why we use exponents, because writing it out like this would be really long and annoying. So the 2 comes down, it doesn't really combine with anything, there's no other numbers in there. And then let's see, we've got 1, 2, 3, 4, 5, 6, 7, 8 x's. So this is 2x to the 8th. We've just got, and then we want to count up our y's. So we've got 1, 2, 3, 4. So that's times y to the 4th and z. So simplified, we should have 2x to the 8th, y to the 4th times z. We can see now that what we needed to do was to add our exponents. Don't forget that when it doesn't look like anything's there, this is really y to the 1st and z to the 1st. All right, then we'll go to b, and I need to erase some of my a. All right, so looking at b, what this is really telling us is that we have 3x squared y to the 10th times 3x squared y to the 10th. So we could write it the long way again, but that would take a really long time. What we would know is that we would have actually 20 y's, so this is y 20. We can see that really all we needed to do was take and multiply that in. Same thing with our x. We'll multiply, so this is x to the 4th. And then here's the one everyone's going to forget. Don't forget, we also have to distribute that 2 into the 3. You can see here, we've got 2 3s. So we have 3 times 3, which you guys know what 3 squared is. 9x to the 4th, y to the 20th. And that will be your final answer. All right, that concludes the study video. We will see you tomorrow in class. Again, if this doesn't make any sense, maybe watch the video one more time, try some more